Hello friends, my name is Alpit and in today's classroom we will be talking about application deployment policies. So first let's understand why do we need application deployment policies. Suppose if you have an application, for example a website which is running across multiple servers behind a load balancer. So for diagram you can see, suppose that if you have an application which is running on 8 servers, or you say virtual machines. So group of servers we can call it as fleet, and these are virtual machines, and there is a load balancer which is using some predefined algorithm to forward customer or user traffic to those servers. Now in this architecture, if you don't have any proper deployment policies, it's possible that during deployment your service is offline. Customer is not able to serve or access your application. That leads to some downtime. So there are different deployment policies where you can control your application behavior during the deployment. For example, downtime, availability drop, and other inconsistency issues. One of the other motivation, if you go to internet, there are many applications which put some phishing page during their deployment, saying they are undergoing maintenance or they are currently offline, will be back soon. This is definitely not a very great customer experience. So there are different deployment policies where you can control this behavior and make your website or application more available and more reliable. Now, so we talked about the benefits. So for example, if you release frequent features and make changes to your applications, you need to deploy them to the servers. And if you have a lot of servers running your application, it will take significant amount of time to deploy them. During the deployment, you need to control the behavior of your application, so you want to have a very good customer experience. To talk about the scope of this discussion or classroom, here we will be discussing about the different deployment policies for similar infrastructure. We will not be talking about different deployment policies for serverless applications or environment or containers. So we also talked about what are the motivations of different deployment policies. Cool. So let's talk about what are the different deployment policies and what are the benefits and disadvantages. So the first deployment policies which we will be talking here is all at once. In all at once deployment policy, you deploy your newer application version to all the instances or server simultaneously. So for example, whenever you have a change, you have a new executable which you need to deploy on servers, all will be deployed at the same time. So what are the benefits or disadvantages of this deployment policy? So let's see the pros and cons of all at once. The first pros which I can think of, it seems to be the fastest or quickest deployment. For example, here the total deployment time would be the maximum time of deploying newer application version to one server. Also, this seems to be the simplest deployment policy, because whenever you make the deployment, you make sure all the servers are deployed with the newer application version, they are running fine, you perform some health checks, and once they are ready to access or serve customer traffic, you put it behind the load balancer. The third benefit, if you can think of, it doesn't incur any cost. So no cost, because it doesn't require any additional resources or server to perform this deployment. Now let's talk about what are the cons of this deployment policy. The very biggest cons of this deployment policy is downtime. So whenever you are having deployment, your service is not available for the customer. Your application is not there to serve customer traffic. That's definitely not a very good customer experience. And if you are frequently releases features or doing deployments, then your service will not be available. So in relation to the downtime, definitely there is a availability impact, and you can say there is a availability drop. So to mitigate the problem of downtime or availability drop, there is a second deployment policy which we can discuss. The second deployment policy is rolling deployment. In case of rolling deployment, you deploy your newer application version in batches. So let's understand what is the concept of batch. So batch means you will take a portion of your fleet, or a group of servers out of the load balancer, you perform deployment, and once they are ready, you put it back to the load balancer, and the same process you repeat with the other servers which are running older application version. So here in here, suppose you pick up a batch size of 2. It seems you want to perform 25% of your fleet deployment at one point of time. So what will happen in case of rolling deployment? You select a batch size of 2 servers, you deploy the newer application version, you perform some health check, and when everything looks fine, you put it back you put it behind the load balancer. Once this is completed, then you pick up another set of batch to perform the deployment, and that's how you repeat the process for the entire fleet. One thing to understand here is you preferably use connection draining in case of rolling deployment. So connection draining is before removing a batch of instance from the fleet, you make sure the load balancer is not sending any newer incoming traffic to those servers. Also, you want to make sure if there is existing traffic or request is served by those servers, you make sure they are completed before you perform the deployment. So that is the connection draining part, and then that's how you perform the rolling deployment. Let's see what are the pros and cons of the rolling deployment. So as you can see, unlike all at once, in rolling deployment, you don't have any downtime, because at any point of time, you have some servers serving the customer traffic. So no downtime. The second benefit here you can see with the rolling deployment is again no cost. You don't require any additional server or resources to perform the deployment. Now, what are the cons of rolling deployment? The first disadvantage I can think of is reduced capacity. Here in this case, at any point of time, you are removing 25% of the fleet capacity to perform the deployment. It means only 75% of the capacity is to serve the customer traffic. So there is reduction in your capacity, which can result in the success rate impact or higher response time, because the servers will be struggling to serve the actual customer traffic. So you can say reduced availability. The second disadvantage I can think here is rollback issues. You think of here at this moment, these 4 servers are running newer application version, whereas these other 4 servers are running older application version. So in that case, if you found some service bug or issues with the newer application version, you need to roll back. So this deployment policy has to be smart enough so that it can only deploy the older application version to the above 4 servers which is running the newer application version. So there are some complexity which you need to be aware while performing the rollback on partially completed deployment. So let's understand how we can mitigate the problem of reduced availability here. So the next deployment policy is rolling deployment with additional batch. In case of rolling with additional batch, you have a additional batch of servers to start the deployment. So here in this case, if you want to have a batch size of 2, then you require an additional batch of instances, that is 2 servers, to start the deployment. You deploy the newer application version to this new batch, and once everything looks okay, you put it behind the load balancer. And then what you repeat the similar process what you did with the rolling deployment. Then you pick up another batch of instances to perform the deployment. So what you see here is at any point of time your original capacity of servers are not reduced. So for example, once you attach the newer batch of instances, you would have a size of 10. Even if you remove another batch of instances to perform the deployment, you would have still fleet size of 8. So let's talk about what are the pros and cons of rolling deployment with additional batch. In addition with the benefits of rolling deployment, in rolling deployment with additional batch, there is a no availability drop. Because you always have fleet capacity of size 8 or more than that, you don't expect a lot of burden on the running servers, and that's how you don't expect any change in the success rate or response time of your application. Let's talk about what are the cons of rolling deployment with additional batch. The first cons which I can think of is cost. Here you require additional servers of the size of batch you select to perform the deployment. So there is some cost. What is the second disadvantage of this deployment policy? The second one is inconsistency. So let's understand what is inconsistency. Suppose if you have a website and you want to change the background color of your web page from red to yellow. So when you in your fleet, if half of your servers are running the newer application version and half of them are running older application version, so all the customer traffic which is going to the newer application version, they will see a web page of background color of yellow. But all the servers who are serving customer traffic, there you will see a background color of red. So there is an inconsistency across customer request. There is also challenge if you have a workflow kind of application where you have non-backward compatible changes. So to mitigate the problem of inconsistency, there is another deployment policy which is immutable deployment. In case of immutable deployment, you create a mirror of your fleet. So here in this case, you will launch 8 servers in a separate fleet. And then you deploy the newer application version to all these 8 servers. Once you see all servers are running fine with the new version and all the health checks and sanity testing is completed, then what you do, you start forwarding the customer traffic to this new servers who are running the newer application version. So suddenly load balancer will start sending traffic here. And after a time, if you see everything works fine, you can delete or kill the older instances or the instances which were running the older application version. But before that, if you see any problem with the newer application version, you will simply kill or delete the servers which are running the newer application version, this one. You won't even touch the original fleet or original servers. So let's talk about what are the pros and cons of immutable deployment. So unlike rolling deployment or rolling deployment with additional batch, you don't see inconsistency here. No inconsistency. Because once you are sure that your newer application version is running fine on new fleet or new set of servers, then you simply forward the newer traffic to this new fleet. Also, make sure all the existing requests are completed before killing the older servers or the servers which were running the older application version. And it also has all the benefits which we see in the past. For example, it won't have any downtime, there won't be any availability drop, and there are no inconsistency. What are the cons of this immutable deployment? The first cons which I can think of is cost. If you have a large number of servers running your application, you need to have that many servers launched separately to deploy the application version. So every time you make a deployment, and if you are making frequent deployment, you would require that many servers to perform the deployment. That adds to your cost. The second disadvantage I can think here is, suppose you have started forwarding traffic to the newer application version and suddenly you found there are some service bug, there are some issues with the newer application version. In that case, you will see there can be 100% customer impact, because all the servers are giving some error based on the bug you had with the newer application version. This is happening because we have not tested any real production traffic before forwarding traffic from load balancer to the newer fleet. So to mitigate the problem of customer impact, you may want to have a gradual transitioning of customer traffic to this new fleet of servers. So to mitigate that problem, we have another deployment policy, which is canary deployment. Canary deployment is a variation of immutable deployment. In canary deployment, you again launch a new fleet of servers with the same size, deploy the newer application version, and when everything is running fine, you don't simply forward all the 100% traffic to this new fleet. You start with probably 1 to 5% of the traffic. So once you forward 1% of customer traffic, you analyze your newer servers or newer application version in terms of if there are any service bug or issues, is there any memory leak, is there any spike in the response time, is there any hit in the success rate. Once you analyze all this behavior, you make sure all your alerts and the threshold alarms are within limit, then you gradually move further traffic to these servers. You can eventually you can gradually go to 10%, 50%, 100%, or you may want to go directly to 100%. So here, what are the benefits of canary deployment? In addition to the benefits of immutable deployment, there is less customer impact, because you are not forwarding all the production traffic directly to this newer fleet. You have a less customer impact in case of issues. Again, it also has typical disadvantages, like the immutable deployment. It's more costlier, it requires longer time to complete your deployment, and there will be still chance of some production or customer impact depending upon how you are forwarding your traffic to this newer fleet. So in today's classroom, we discussed about different application deployment policies and how those policies can help you have better application availability or reliability during the deployment.